Hello and welcome to my QT008 presentation assignment. My passion is hiking. Hiking can be physically tolling, and it has some amazing views, especially over nature and high places. The issue I'm tackling today is blind hikers. They are blind, and so they cannot see, and therefore they have no visual indication over their surroundings. Typically, blind hikers take a guide dog with them. And to narrow it down further, I have a friend called Albert. He's half blind and he wants to go on hikes, but he says that his problem with getting lost and dark when it's dark uh, prevents him from going on hikes. And so my microbit solves this problem by assisting blind hikers in detecting light levels and helping them telling them when it's getting too dark or starting to get too dark. This also could be a general use thing to help track steps, and by extension, it could call for help because Microbit has that functionality. Now let's move on to the code. Here is my microbit, but instead of looking at the code, we'll jump straight into the functionality of the microbit shown here. On first start, the microbit would ask the user on which input they want, where A is for the longer hike and B is for the shorter hike. So in this case, we will use we'll go for the longer hike instead because it has more functionality. And you can see that there is some other stuff present on um, the screen. We will go through them later, but right now we'll press A. And the first thing right after pressing A you will see is that it will print out telling the user that they have selected A and they are going on a longer hike. Uh, and then if we press on A again right after this, the light function will start running where it records the light. So there is different types of conditions that needs to be met for different stuff to happen. And right now, the first thing you will see is that you see the whole screen isn't being lit up. You can see the diamond shape where there's like four squares not lit up. But then if you move it to the very top, say over 200, then it will all light up, telling the user that it is very bright outside. And then it just ran again without me pressing. This is the 50-second condition that runs whenever it is active. This is in the forever loop. And if I were to run this multiple times under 200, for example, the first one being 178, the next one dipping at 153, and the one after that dipping at, for example, 111, and it'll play that sound telling the user that it is getting dark outside and it is the light level is decreasing steadily. And if we set this, okay, it goes to 0, but if we set this to 0, it'll play another sound as well, telling the user that it is very dark outside. And then another functionality is that there's the shake button. If we just press this a few times, then it will basically act as a counter to how many steps the user is taking. And if we press on A plus B, this is the end hike button, and A is yes, B is no. And if we press on B, it'll go back to the regular functionality, and A will just end it. And after ending it, it will show you how many steps they are, depending on how much you've shaked. And then this is the code right here. The on start, there are a lot of conditions. So this on start will not be repeated if the start hike started variable is set to true. And then started is always set to started is always set to true on start. The light level recorded is an array that's always set to empty on start, so it doesn't get transferred between different hiking sessions. And for A and B, essentially both are going to set started condition to false to stop the on start from running again, and then hike started to true. Started just basically stops this part of the script from running on both A and B. So when uh, started is false, then it will always run late function when you press A, for example. And then if you press A, the hike length is set to 1. Vice versa on hike B, on B button pressed, it was set to 0. And these basically go into light functions where it detects light. So when you press A, light function will run, and then on if light level is more than 200, then it will show you that it's bright outside. If And they'll run this other function that we'll get to in a bit. But if light level is between 200 and 100, then it'll show this icon instead and show the light level. Oops. But if the light level is decreasing and it's detected and your hike is very long, then it will call the light level. It'll just make this it'll just show these icon and make a sound telling the user that it's getting dark outside. And then afterwards, if the hike length is 1 and it's less than 100, then it'll make a sound and show that the light level is decreasing. Otherwise, it won't make a sound if you're on a shorter hike, because you wouldn't need to. Um, you will still need to know that it's getting dark, but you won't if you are not in a bigger urgency to get back to your car or your mode of transport. And then afterwards, there's the light level recording. It records the light level, puts it in an array, and then uses the array to check if the light level is decreasing throughout each different recordings. And then it'll set the light decreasing detected to true, which basically triggers this right here, this function right here, which requires it to be true. And otherwise, it will set it to false. And the length of the array, if it's more than 4, then we'll remove it to just keep it clean and not clumped. And then right here, there is the A and B end hike button, and then the forever loops that runs. The first one runs every 50 seconds. The second one basically just checks if the user's falling. And on free fall, it'll set this to true. Set falling check to true to make a sound every time. And then on shake, it will add a step. And then if you want to end it, then it'll set the pressing A and B, it'll end the hike. And then if you press A again, it'll stop everything from happening and then show the steps counter. And to stop the falling check sound from happening right here, then you just press on B. And that's the functionality of my microbit. And then onto algorithmic thinking. This My microbit uses a variety of inputs to process them in if and if else statements, and then outputs them in a LED light and sound format where there are different types of sound depending on the different conditions. And this microbit continuously runs until the user ends it, or the user like keeps it running. And this microbit uses arrays to store information and processes them through conditions to output audio cues. And I've used problem decomposition skill to separate out the different functionalities. This also helps uh, with easier presentation and better cohesion. Um, because I've separated them out, so because they are fundamentally different tasks. One is the back end, and one is the front end. And then I've used pattern recognition skill to find that the light level decreases in the afternoon and evening, which is where this microbit is mostly used for, to detect the light level before it gets dark. And it helps just the whole microbit function. And then I've used abstraction to simplify the light level to store into a byte where there's 255 different combinations of levels, and then extrapolated it upon these light levels for my microbit functionalities. And then some of the possibilities are you could expand more onto the functionalities of the microbit. For example, using a radio system where it could measure distance between the guide dog and the blind hiker, or in a general case, it could just be a friend to another friend. And another thing that could be added onto the microbit is that they could guide a microbit to another. This may be a limitation as well because I'm not sure if microbits has that functionality. But the limitation is that there's no timer inside the microbit, so if the user is under shade, it could count technically as the light level decreasing. Um, yep. And thank you to my presentation, and have a nice day.